All right, in the previous video, I decided I was going to integrate this with a trig substitution by letting x equal sine of t. Then I have to take the derivative, dx equals cosine of t dt. Now, a student asked me, can I let x be cosine t? And I said, sure, yeah, but this derivative is going to be negative. So we kind of want to stay with sine because when you take the derivative, it eliminates the need to have to mess with a negative, which we all hate. All right, so let's see. If I go ahead and do this one here, this is equal to the integral from x equals 0 to x equal 1/2 because I'm changing everything to t, so that's going to be an x. Now, I may change those in a minute, but let's just go from here. So x squared becomes sine squared t. Dx becomes cosine t dt, and on the bottom I get the square root of 1 minus sine squared t. So x is sine t, so that's why it's sine squared t on the top. Cosine t dt is dx, and I replaced x down at the bottom with sine squared t. So now I just simplify for a little bit to see, make it easier. I mean, that's what we all want, right? So x equals 0 to x equal 1/2. And in the numerator, I still have sine squared t cosine t dt. But at the bottom, that turns into the square root of cosine squared t by the Pythagorean identity. Now, continuing on, this is going to equal, let's see, this is down here is just cosine t. So I know that this guy and this guy are going to be a factor of 1. So what I'm left with is sine squared t dt. Now, to be honest with you, I'm not too excited about changing the limits here or leaving them in x, because that way I don't have to put it back in x. I can just do everything in t. So let's change it from x equal 1/2 to x equals 0 to t. So I know that x is sine t, so that when x is 1/2, what is sine t? That's a question I want to answer. And then when x is 0, I want to know what t is based on that. Well, using the unit circle, I'll draw a little tiny unit circle here. When sine is 1/2, I want to know what angle makes that. Well, sine is 1/2 at about pi over 6 degrees. So that means t, when x is 1/2, t is pi over 6. And then when sine is 0, which is right here, I know that my angle is 0. So here t is 0. So my limits now in t will go from 0 to pi over 6. That's nice. Now, in order to integrate this, I'm going to use the tables. Number 17 with n equal 2. Now, a lot of students say, do I have to write that down? I'll say, well, if you want to get it right, right? So it's not going to hurt you to take a few seconds to write that down in order to make sure you use the table right. Now, looking at the table, I get minus 1/2 sine t cosine t plus 1/2 the integral of sine of to the 0 t dt. I'm almost out of paper there on that end. If I keep going, oh wait, I have to remember because I have limits, 0 to pi over 6, 0 to pi over 6. Don't forget those. So I have minus 1/2 sine of t cosine of t from 0 to pi over 6 plus 1/2. Now sine of 0 is just 1, so I'm going to integrate from 0 to pi over 6 1 dt. I don't know why I make ones like that in this case, but I do. Keep going. Minus 1/2 sine of t cosine of t from 0 to pi over 6 is equal to, or plus, excuse me, 1/2 t plus c. No, not plus c. See, it's hard to remember how to do this because, you know, we're so used to doing the indefinite. Here's a definite one. We have to always remember that stuff. Okay, this is a 6. Now, let's keep going. I think actually I can plug in my limits as is. So let's just be real careful and use a fundamental theorem right, and it should come out. So I have 1/2 sine of pi over 6 cosine of pi over 6 minus 1/2 sine of 0 cosine of 0 plus 1/2 pi over 6 minus 1/2 times 0. All right, I'm going to slide this up just a tiny bit. This is equal to, okay, now let's remember our trigonometry. Exact values here, people. You should remember that unit circle. Sine of pi over 6 is 1/2. Cosine of pi over 6 is square root of 3 over 2. Look it up if you don't know. Go Google unit circle, and most likely somewhere around there it's going to pull up the one that's going to give you these values. Memorize them. Plus 1/2. Sine of 0 is 0, so it doesn't matter what the cosine of 0 is. Plus pi over 12, and then minus 1/2 times 0 is 0. Now all I'm going to do is simplify a little bit, and then we should be done. So I have minus square root of 3 over 2 times 2 is 8. So minus square root of 3 over 8 plus pi over 12. And how do we say this is the area under the curve above x-axis. So if it's area, that's going to be some units squared. All right. If you have any questions, watch it again.